Okay, so horizontal asymptotes, obviously their lines go on the other way, and my calculator doesn't mess this up as badly. But even in that little example I had, where it was something like this and this, these L's are kind of tapering out along the x-axis. But it doesn't have to be along the x-axis. It could be somewhere else, like that. And so the question is, where is it tapering out? You don't have to graph anything past where it starts just doing that tapering out thing, because everybody knows how it goes from there. So the way you do that is more complicated than setting something equal to 0. 3x squared over x squared minus 4. Okay, now if the two powers, we're just looking at just the highest powers, if they're the same as each other, 3x squared and x squared, okay, if they're the same as each other, just write those down. I don't need the minus 4. And then the x squareds will cancel, because x squared and x squared, that'll cancel. That's where my line would be. The horizontal asymptote is at y equals 3. That is the answer to where's the horizontal asymptote for that. Now the other one, if okay, the powers are different. The highest power I see here is 5x, and the highest power I see there is x squared. If the power on the bottom is bigger, (5x versus x squared), I don't need any of this other stuff. But if the power on the bottom is bigger, then the answer is x-axis. So that covers what to do if the powers are the same. If the power on the bottom is bigger, well, what if the power on the top is bigger? If the power on the top is bigger, it doesn't actually have a horizontal asymptote, so you wouldn't have to answer anything for that. But what it will have is a slant asymptote, so we're going to have to do that in a whole separate section.